This is a real Spotify Connect player. I can select it directly from the Spotify app, stream music to the Vectrex original speaker, display the current track and artist on its vector screen, and control everything using the original joystick and buttons. And yes, that Spotify logo is 3D. The unusual part is that Vectrex was released in 1982. So, how do you turn a console from more than 40 years ago into a modern streaming device? And why did getting the screen and speaker to work together become the hardest part of the entire project? I have always been a huge fan of the Vectrex. Unlike almost every other console of its time, it does not connect to a normal television. It has its own built-in vector CRT. Instead of constructing an image from rows of pixels, the Vectrex moves an electron beam directly between coordinates, drawing every line individually. That is what gives games like Mindstorm their incredibly sharp, glowing, and almost holographic appearance. There is really nothing else quite like it. There are even some great accessories for it, like the light pen and the amazing 3D imager. Yes, a stereoscopic headset again. This is 1982. For this project, I'm using a PiTrex. The PiTrex is a cartridge that allows a Raspberry Pi to take control of the Vectrex hardware through its cartridge slot. In my setup, it is connected to a Raspberry Pi Zero-W. That gives me Linux, networking, and enough flexibility to run a Spotify client. But the Pi Zero-W is a tiny, single-core computer. Asking to decode a Spotify stream while controlling a 40-year-old vector console turned out to be quite a challenge. The experience I wanted was simple. When the Vectrex starts, it should appear inside Spotify as a device called Vectrex. I should be able to select it from my phone and immediately begin streaming music. The audio should come from the Vectrex original speaker. The screen should display the current title and artist. The controller should handle playback, volume, and the visual modes. And the entire system should start automatically whenever I switch on the console. It sounded reasonably straightforward, but the Vectrex has one very unusual limitation. The Vectrex uses a digital to analog converter, usually called a DAC. This DAC generates the values used to position the electron beams on the screen, but it is also used to produce digital audio. The screen and speaker are effectively competing for the same piece of hardware. When the Vectrex is drawing, it cannot output an audio sample at the exact moment. And when it's outputting audio, it cannot move the beam to draw the next line. So the entire project became a question on how to divide one DAC between two completely different jobs. Who gets it, the speaker or the screen? For Spotify Connect, I initially looked at some of the usual Raspberry Pi solutions. The problem was that the Pi Zero-W uses the older ARM v60 architecture, and many modern Spotify clients no longer support it properly. Eventually, I found an open source client called Go LibrarySpot that could run on a Pi Zero. It announces itself to Spotify as a Connect device called Vectrex and output a raw stream of audio. My C program received that stream, converts it from stereo to mono, reduce it to 8-bit audio, and send it to the Vectrex. At least that was the plan. My first version used a sample rate of 11 kHz, and it sounded terrible. There was a regular interruption roughly once every second. At first, I thought the audio timing was simply inaccurate, but the real problem was the Pi Zero. The problem was waking up more than 11,000 times every second to output audio. On a modern computer, that would be trivial, but on a single-core Pi Zero, the output loop was using so much processing time that Spotify could not decode the incoming stream quickly enough. The buffer will gradually empty, and every time you ran out of data, the audio clicked. The solution was slightly counterintuitive. I reduced the sample rate to 8 kHz. That meant the audio loop ran less frequently, giving the Spotify decoder more time to work. The buffer remained full, the clicking disappeared, and the playback became stable. Of course, 8-bit mono audio at 8 kHz is not exactly high fidelity. It sounded more like an old telephone, a vintage radio on an early computer, but on a Vectrex that feels strangely appropriate. The music remained clearly recognizable, and it is generally playing through a speaker originally designed for an arcade blips, laser and explosions. Once the audio was stable, I still needed to use the display. Because sound and graphics cannot use the DAC simultaneously, the program alternates between them. Most of the time, the DAC produces audio. Around 25 times per second, the program briefly pauses the audio, gives the DAC to the display, draws the text and graphics, and then returns control to the speaker. The drawing window only lasts a few milliseconds, but even that creates a problem. While the image is being drawn, the audio stream is still moving forward. To prevent playback from gradually falling behind, the program measures how long each drawing burst takes and compensates by skipping the corresponding amount of audio. This keeps everything synchronized, although complex graphics can introduce a faint texture underneath the music. The trade-off is unavoidable. More graphics mean less time for audio. Simple graphics mean clearer sound. One of the display modes even turns the screen off completely, giving a DAC entirely to the speaker. This is definitely not an audiophile device. It is Spotify working through the original architecture of a console from 1982, and that is exactly what makes it interesting. Displaying the current track created another collection of problems. The original PiTrex vector font only supports a limited range of characters. Lowercase letters, accent, and unusual symbols can produce complete garbage on the screen. So every track title and artist name has to be converted into clean uppercase text before it reaches the Vectrex. The system also calculates the size of each line automatically. Short titles appear large, longer titles shrinks to fit, and if a title is still too long, it becomes a scrolling marquee. A small Python program retrieves the Spotify metadata and passes it to the main C application controlling the Vectrex. It is quite a lot of engineering just to display the name of a song on a 40-year-old screen. Originally, I considered displaying a simple flat Spotify logo, but the Vectrex is famous for wireframe graphics. It was practically made for rotating three-dimensional objects. So, I built the Spotify logo as a real extruded 3D model. As the logo rotates, it looks almost like a small coin or a medallion floating inside the screen. Because every line takes time away from the audio, the model is intentionally low poly. When it fills the screen, it can be large and chunky. When it appears beside the track information, it uses fewer lines and becomes less expensive to draw. In full screen mode, the original Vectrex joystick controlled the rotation. Left and right adjust the yaw, up and down adjust the pitch. And selected orientation is remembered when it moves between the different visual modes. The original Vectrex controller operates the whole experience. Button 1 selects the previous track, buttons 2 play or pauses, button 3 select the next track, and button 4 cycles through the display modes. The finished system appears as a real Spotify Connect client. It streams music through the original Vectrex speaker in 8-bit mono at 8 kHz. It displays the current title and artist using low-in vector text. It renders and extrudes a 3D Spotify logo. It supports multiple display modes. It provides playback, volume, and visual controls through the original controller. It remains interactive while paused. And the entire system starts automatically when the console is powered on. All of this runs on a single core Raspberry Pi Zero W connected through PiTrex. Mission accomplished. This project started because I wanted to celebrate Vectrex, not by replacing that make it special, but by using its original display, controller, speaker, and even its limitations. That shared DAC was the biggest obstacle, but it also became the defining feature of the project. The Vectrex was designed to draw glowing wireframe graphics and produce arcane sound effects. More than 40 years later, it is now streaming Spotify, displaying track information and rendering a rotating 3D logo, all through the same hardware it has had since 1982. Is it the best sounding Spotify player ever made? Definitely not, but it might be one of the most memorable. I'll share the files, build nodes and links in the description. If you build one, modify or improve it, let me know. I would love to see what you make. Thanks for listening.
Vectrex scan。映像はここまで進化した。圧倒的迫力で未来を打つ、未来を描く。コンピュータプレイは未体験ゾーンへ。ベクトルスキャン映像高速線。